In example 1 here, we need to solve a nice word problem, and this is relatable to physics, I suppose. And so it says Mrs. Volson and daughter Elena are putting up some scaffolding, and so that they can work on one side of a cabin. To hoist the scaffolding up, they're using 2 ropes. Mrs. Volson is pulling on one rope at an angle of 65 degrees and a force of 400 newtons. And Elena, oops, should have switched that name, is pulling on another rope at an angle of 110 degrees with a force of 600 newtons. And we're wondering how much force is exerted on the scaffolding. So on the right hand side, this doesn't work every single time, but this is something that you can do with a problem like this. So what we're going to try to do is find the x and y components of each one of the vectors, and then we're going to add the vectors together. So essentially what we're doing is we're going to find the resultant vector. Then once we find the resultant vector, we can find the magnitude and the direction if needed. Here we really don't need the direction. So what I like to do with these is first of all draw a picture. So here's my scaffolding. And then we have a 65-degree force pulling up on the scaffolding, so that might be here. And that's at 400 newtons. And then the other one is 110 degrees at 600 newtons. So that might be over here. And again, that angle here would be 110 degrees. So now we need to find those x and y components. Now that might be a little bit difficult if you didn't know any trigonometry, but we do, and so we can figure out each one of these. This is really the same thing as finding x and y when we talked about polar equations and figuring out changing between polar equations or changing between polar points and rectangular points. So for the first vector, to find the x component, that's going to be the hypotenuse times the cosine of 65. And if you prefer, you can set this up as the cosine of 65 equals x, which is the adjacent side, over the hypotenuse, and then solve for x. But you're going to wind up with this equation right here. We can type that in the calculator. One thing you need to do is make sure that you're in the correct mode. So I'm in degree mode. I'm using degrees. That's what I want. So we'll do 400 times the cosine of 65. That's 169. We'll just round here. And then for this one, y is going to be 400 sine of 65. Little trick, if you just hit second enter, cursor over, and hit sine, 362.5. So let's make that 363. Now we'll do the second vector. So that was this guy right here. And then we'll try the other one here, maybe in, let's do purple. So this vector is going to be in purple. So that's going to be x is equal to, this time it's 600 times the cosine of 110. So we've got 600 times the cosine of 110. Gives us about negative 205. By the way, the direction is important. And then if we just hit second enter, cursor back over, and hit sine, that'll give us the y component. Oops, that's a sign there. So this is 564, and that should be positive. So now all we need to do is we need to add these guys together, and that'll be our resultant vector. So if we add them together, we've got 169 minus 205. That's negative 36. And then if we take 363 and add 564, we're good to go. Now if we want to find the magnitude, remember that's just the square root of the x part x component squared plus 927 squared. So we'll knock that out in the calculator real quick. And that's 927.7. Or we could say 928. And we want to make sure that the force is stated correctly, so that'll be in newtons. We don't have to find the direction, we just want to find that force on the ladder.